Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. In the last lecture we were discussing about surface area and volumes, introduction, and then we discussed about surface areas of a combination of solids, right? And we took some examples also. Now we will move on to the exercise based on surface areas of combinations of solids. So let's see our first question here. We have got two cubes, each of volume 64 centimeter cubed, and these are joined end to end. Okay, let us say these are the two cubes we are talking about. This is one cube. What is a cube? Cube has all the edges equal, right? In a cuboid we had a length, breadth and height which were not same, right? When these are same, it becomes a cube. Now we are joining two cubes together end to end like this. Right? Let us say these two cubes are joined. Now each of these cubes has volume 64 centimeter cubed. Let us say the length, breadth and height of this cube is A, right? One of the cubes. Now volume is given by A cubed, right? It is equal to 64 centimeter cube, right? So what is the length of the edge of the cube? It will be given by A 64 cube root, right? And what is 64? It is 4 into 4 into 4. So it is equal to 4, right, in centimeter. So this is the length of the edge of the cube. Okay. All right. We need to find surface area of the resulting cuboid. Now if you see, when I joined these two cubes, it becomes a cuboid, right? What are the dimensions of this cuboid? This height will not change, it will still remain A. This breadth will not change, it will still remain A. But this length here has changed, it has become 2A. So if I talk about the dimensions of the cuboid, these are 2A, A and A, right? What were the dimensions of each of the cubes? A and A. When I joined two cubes together end to end, it gave me a cuboid with dimensions 2A, A and A, right? Now I need to find the surface area of this resulting cuboid. So surface area of the cuboid is equal to, we learnt a formula for it, right? In a cuboid where length, breadth and height were given by LB and H, what was the surface area? It was twice of LB plus BH plus HL, right? So we will put these values 2A, A and A in place of L, B and H. So what is surface area of cuboid? It is equal to twice of L should be replaced by 2A, B by A plus B by A, H by A, H should be replaced by A, L by 2A. So this will give me the surface area of the cuboid, which is equal to twice of, this is 2A square, this is 2A square, right? So 4A square and this is A square. So 4A square plus A square is 5A square. Okay. So this is effectively 10A squared. Now what is A? A is 4 centimeter. So let's put A equal to 4 here. So this is 4 squared, hence it is equal to 16. 4 square is 16 into 10, 160. Now the unit will be centimeter square, right? Because we are talking about surface area. Okay. So this is how we can join two cubes to make a cuboid, and the difference in both dimensions will be only in length. Breadth and height will remain the same. Okay. So one dimension will change only. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. So there is a hollow hemisphere. Let us say this is the hemisphere and this is mounted by a hollow cylinder. So this is how it is mounted by a hollow cylinder, right? Okay. The diameter of the hemisphere is 14 centimeter. So this diameter here is 14 centimeter. Hence, I can say this radius is 7 centimeter, right? So this is also 7, because this is also radius of the hemisphere. Now, the total height of the vessel is 13 centimeter. So the height from here to here is 13 centimeter. So if I want to calculate the height of the cylinder, I will have to subtract this 7 from 13. So this height is 6 centimeter, right? Because 7 plus 6 is 13, which gives me height of the vessel, right? Find the inner surface area of the vessel. So what will be the inner surface area of this vessel? It will be equal to the sum of surface areas, inner surface areas of the hollow cylinder and inner surface area of the hemisphere, right? I am talking about this surface area here, this one for hemisphere and this one for cylinder. So what will be the inner surface area of this cylinder? It will be equal to 2 pi RH, where R is radius, H is height. So if R is radius, H is height of cylinder, right? Radius R is same for the cylinder as well as the hemisphere. So what will be the inner surface area? Inner surface area of the vessel is sum of surface areas of the hollow cylinder, that is curved surface area of the cylinder, which is 2 pi RH, plus the surface area of the hemisphere, which is 2 pi R square. Okay. So this will give me my result. So what is R? R is 7. What is H? H is 6. So we will just replace these values. Let's take 2 pi R as common. 2 pi R as common. So it will be H plus R inside. So let's replace R by 7. So 2 into 22 by 7 into R is 7. H plus R. So H is 6, R is 7. Okay. So this 7 gets cancelled. 7 plus 6 is 13. 13 into 2 is 26 into 22. 26 into 22 can be calculated like this. 275. So it is equal to 572 centimeter square. 572 centimeter square is the surface area, inner surface area of the vessel, which is a combination of a cylinder and a hemisphere. Now I have got a toy which is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of the same radius. So there is a hemisphere and a cone is mounted on it, and this cone and this hemisphere has got same radius. So if I talk about this radius here, this is 3.5 centimeter, 3.5 centimeter, right? So this is also 3.5, right? Total height of the toy is 15.5 centimeter. So if I talk about this height, it is from here to here, it is 15.5 in centimeter obviously. So if I ask you the height of this cone, it will be 15.5 minus 3.5, right, which is 12. So this is 12 centimeter. So height of cone is 15.5 minus 3.5, which is equal to 12 centimeter, right. We need to find total surface area of the toy. Now for total surface area, I need to calculate this curved surface area of the cone, right, and this surface area of the hemispherical part. So for this I need pi r L, where r is radius, L is slant height. So I need slant height of the cone, right. Let us say this is L, let's denote it by L. So what is slant height L? It is equal to r square, which is 3.5 square, plus h square, height square, right. So 12 square, square root. Okay. So let's calculate it before proceeding. 3.5 can be written as 7 by 2, so square it, plus 12 square, square root. So it is equal to 7 square is 49, plus 12 square is 144, right, and divided by 4. So this is equal to 49 plus 144 into 4, it is equal to 576, and it is divided by 4. So this is 625 divided by 4, hence 25 by 2, which is equal to 12.5 centimeter. So this is the slant height. Okay. Those who know about Pythagorean triplets, they could have calculated it simply, because this 2 square will multiply with this, so it will become 24 square. 7 square plus 24 square will give you 25 square. Okay. 7, 24 and 25 are Pythagorean triplets. Okay. Okay. So we have got the slant height now. So what is the total surface area of this toy? It is equal to total surface area is equal to pi r L, which will give me the conical part surface area, plus 2 pi r square, which will give me the hemispherical part surface area, where L is slant height, r is the radius, and this r is also a radius, both are same. Okay. R is equal to 3.5. So if I take pi r common, I'll have L plus 2r inside, right. So L is 12.5, r is 3.5. So pi is 22 by 7, r is 3.5. So I'll replace it by 7 by 2. 7 by 2 is 3.5. L is 12.5 plus 2r. So 2 into 3.5 is 7, right. So this 7 gets cancelled. 2, it will give me 11 here. So 11 into, this is 12 plus 7 is 19. 12.5 plus 7 is 19.5, right. Now the calculation becomes very simple. 195, 195. So this will give you 5, 4, 1, 2. So this will be equal to 214.5 centimeter square. So this is the total surface area of this toy, okay, which is a combination of a conical part and a hemispherical part. So hemispherical part gave me 2 pi r square, conical part gave me pi r L. The only challenge in this question was to calculate L, right, slant height, and then we should know the formula and simply place the values. A cubical block of side 7 centimeter is surmounted by a hemisphere. This time we are given a cubical block. And what is the side of this cubical block? It is 7 centimeter, right. It is surmounted by a hemisphere. What is the greatest diameter of the hemisphere that we can have? So greatest diameter will be it will be a circle which will touch all these sides. So what will be the greatest diameter? It will be equal to the edge of this cube. So greatest diameter will be equal to 7 centimeter, right. because we are talking about this hemispherical portion which is surmounted on this cubical block. So, the greatest diameter will be given by the biggest circle that we can draw in the top face, which is a square shaped, right. If I have got a square, what is the biggest circle that I can draw? The circle that will touch all the sides, right. So, what will be the diameter? It will be equal to the edge. So, the greatest diameter is 7 centimeter. Now, we need to find surface area of the solid. Now, that it has become a solid, so this circular portion on the square side, right. If you only consider the top of this cube, this is a square shape, right. When I put a hemisphere on it, this circular portion gets covered up, right. So, if let us say the edge is A, right, what is the total surface area of the cube? 6a square. Now, I have put a hemisphere on one of the faces. So, it will take away pi r square, this much area, right. So, I will have to subtract pi r square. What is r? R is half of A. This much area is gone, right, but we have got a new area which is hemispherical. So, it will give us a surface area of 2 pi r square. So, 2 pi, what is r? R is half of edge. So, this will be effectively my surface area for this solid. We already know the value of A, which is 7 centimeter. So, this is 6a square. This is 2 pi a by 2 square. This is 1 pi a by 2 square. So, effectively I have pi a by 2 squared. So, let us put value of A as 7. So, if I take this is 6 into 7 square plus pi as 22 by 7, A will be replaced by 7 here. So, 7 by 2 into 7 by 2. So, this is my calculation part and the unit will be centimeter square, right. So, this is 6 into 49, this 7 gets cancelled, it will give me 11. So, this is 77 by 2, right. So, this is 6 9s are 54, 5, 294 plus this is 38.5. So, if I add these, (332.5) centimeter square is my answer for this surface area. This is the total surface area. Total surface area, right. So, we need to understand that if I put something on a solid, the area which is common to both, right, which is overlapped, this area will not be considered as area of this solid, right. This area has to be subtracted, this area, right, and this is the new surface that we have got by mounting this hemisphere on the solid. So, this has to be added, okay. A hemispherical depression is cut out from one face of the cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. This time, a hemispherical depression is cut like this. Let us say this is our cube, okay. So, a hemispherical depression is cut from here, right. This goes inside, okay. So, this is circular, this face, right. So, I had a solid cubical block, wooden block, and I cut the depression in one of its face, and this is diameter L of the hemisphere is equal to the edge. So this is the biggest circle that I can draw on its face, right? Its diameter is L, right? So the edge will also be L. So if I talk about the radius of the hemisphere, radius R of the hemisphere is L by 2, half of it, right? This is radius of hemisphere. Now, what will be the surface area of the remaining solid? What is remaining solid? We have got a cubical block and one face has got this depression, hemispherical depression. So, there is no change in 5 faces of the cubical block. So, if I write total surface area of the remaining solid, it will be equal to, so this length was L. So, what was the total surface area of the cubical block only if we didn't have any depression? It was 6L square, right? Now I have got this depression. So, this circular area on this top of the cubical block is vanished. So, I have to subtract the area of this circle, pi r square. Now, this is the new surface that has generated in this, right? The depression, the curve of this depression, right? What is that area? It is equal to the area of the hemisphere, right? Curved area of the hemisphere, right? Which is 2 pi r square. What is radius? L by 2, right? So, this is the effectively the area of this solid, which is equal to 6L square. This is 2 pi, this is 1 pi L by 2 whole square. So, effectively it is pi L by 2 whole square, right? So, you can see L square we can take as common. From here 6 plus this is pi and this 2 square will become 4, right? So, it is equal to L square by 4, 24 plus pi, and we do not forget the unit. Unit is not given, so we will write square units. Square units, because we are talking about area here. If we were talking about the volume, we would have said cubic units. So, this is in square units, right? Okay. Now, I have got a medicine capsule which is in the shape of a cylinder with 2 hemispheres stuck to each of its ends. So, there is a cylinder like this. Okay, let us say this is a cylinder, and these are 2 hemispherical portions which are stuck to both its ends. Now, the length of the entire capsule, so from this end to this end, the length is 14 mm, right? Diameter of the capsule is 5 mm. So, what is the radius of this capsule? It is 5 by 2, that is 2.5 mm, right? So, this is also 2.5, hence this is also 2.5. So, if I need the height of this cylinder or this length from here till here, right? If I need this length, I have to subtract this 2.5 and this 2.5, right? So, if I denote it by h, so what is h? Height of the cylinder, which is 14 minus 2.5 minus 2.5. So, 14 minus 5, it will give you 9 mm. It is the height of the cylindrical part. I need to find its surface area. So, what I am looking for is this surface, which is the curved surface, total surface area is equal to this curved surface area of the cylinder, curved surface area, CSA, curved surface area of this cylindrical part, plus this surface area of the hemispherical part, right, plus this hemispherical part. So, twice of surface area of hemispherical part, right, only the curved surface area. So, that is 2 pi r square. So, now if I denote it by r, this radius 2.5, let us say this is r. Just to write it in a formula form, what I can write is CSA of cylindrical part. So, I will write it 2 pi r h, where r is radius of the cylinder as well as the hemisphere, plus surface area of hemispherical part twice of 2 pi r square, where r is the radius of the hemispherical part, which is equal to this, right. H, I have already told, is the height of the cylindrical part, and we have calculated it equal to 9 mm. R is 2.5, so let us put the data. 2 pi r, if I take common, I will have h here and 2r here, right. 2 into 22 by 7 into r is 2.5, right. So, let me take it 5 by 2, right. H we have calculated is 9 plus r is 2.5. So, 2 into 2.5 will give me 5 here, clear. So, this 2 gets cancelled. So, this is 22 by 7 into 5 into this is 14. So, this will give me 2, 5 into 2 is 10. So, 220 mm square or square millimeter is the surface area. Okay. Okay, let us move on to the next one. Now, we have got a tent which is in the shape of cylinder surmounted by a conical top. So, let us make a rough diagram. These are rough diagrams, right? These are not the exact diagrams. There is this cylindrical tent surmounted by a conical top. If the height and diameter of this cylindrical part are 2.1 meter and 4 meter. So, height is directly given as 2.1 meter. So, this is 2.1, right, and diameter is 4 meter. So, radius is 2 meter. So, this is 2, okay, this is also 2, okay, and the slant height of the top, it is directly given, is 2.8 meter. So, this is 2.8, right, the unit is meter everywhere. Find the area of the canvas used for making the tent. So, which area are we talking about? This curved surface area of the cylindrical part and this curved surface area of the conical part. So, which is equal to total area of the canvas used for the tent is effectively equal to curved surface area of cylindrical part plus the curved surface area of conical part. What is curved surface area of the conical part? It is pi r l, where r is radius, l is slant height, right. This is what we already know. Curved surface area of the cylindrical part is 2 pi r h, where r is the radius, h is the height of the cylindrical part. So, we need to calculate 2 pi r h plus pi r l. Pi r we can take as common. So, 2 h plus l. Let us put pi equal to 22 by 7. What is r? R is 2. What is h? H is 2.1. So, 2 into 2.1 is 4.2 plus l. L is 2.8. So let's put it equal to 2.8. So this is 44 by 7. 4.2 plus 2.8 is equal to 7. So this 7 will get cancelled. So it is equal to 44 meter square. This is the total area of the canvas used to make this tent. Now the next part of the question says, find the cost of the canvas of the tent at the rate of rupees, or we denote it by this symbol, rupees 500 per meter square. So for 1 meter we have to spend 500 rupees. How much will we have to spend for 44 meter square? For 1 meter square, the cost is 500 rupees, right? So for 44 meter square, the cost will be 44 into 500, right? So which is 22,000 rupees. So this is your answer, 22,000. Okay, and this is the unitary method, right? We calculate the cost for 1 unit, 1 meter square, then we multiply it by 44 because we need to calculate the cost for 44 meter square. So this is how we will proceed for this question. In this question, the data was directly given, so we just had to remember these formulae and then we put the values. Okay, for the calculation part of cost of the tent, we just applied the unitary method, which we studied in junior classes. Okay, from a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, we have got this solid cylinder with diameter 1.4 centimeter. So what will be its radius? 1.4 by 2. So this is 0.7. It is the radius, right? And what is the height of the cylindrical portion? Let us say this is the cylindrical portion. This height is 2.4 centimeter. A conical cavity of the same height and same diameter is hollowed out. So this is the conical cavity we are talking about, right? So this portion is taken out from this solid cylinder. So what I am left with is a shape like this. This is the shape that I am left with. This is the solid part. This is also solid part. Okay, so there is a cylinder and there is this conical cavity. Now I need to find total surface area of the remaining solid. So what will be the total surface area of this solid? This base, let us say the radius is r. So this base will give me pi r square, and this surface, the curved surface area of the cylindrical part, if the height is h, so it will give me 2 pi r h. Okay, and this new surface that is generated because of the hollowing out of the conical portion. So this surface has area pi r l, where l is the slant height of the conical portion. Okay, so now what I need to calculate is, first of all let's write l is slant height of cone. Okay, h is height of cylinder, r is radius for both cylinder and the conical part, right? So I have got r already, which is 0.7, I have got h, which is 2.4, I need l to proceed with the calculation part. So this is l, right? So if I apply Pythagoras theorem, L square is equal to 2.4 square plus 0.7 square. Those of you know about Pythagorean triplets, we know that 7, 24, the third number will be 25. Or if you want to calculate, you can calculate 7 square is 49, 24 square is 576, If you add these, you will get 625, which is 25 square. Okay. So this will effectively give you 625, and then the decimal will be 6.25. Okay. So this is for L, right? Because this 2.4 square will give you 5.76. 0.7 square will give you 0.49. If you add these, you will get 6.25, right? So you need to take square root of 6.25 now. Okay. For L, you need to take square root of 6.25. So which is equal to 2.5. So this is my slant height, 2.5 centimeter. Right. So now I have got slant height also. So what will be total surface area of the remaining solid? So total surface area is equal to pi r square plus 2 pi r h plus pi r L, right, where r is 0.7, h is 2.4 and L is 2.5. So let's put the values. Pi r and pi r can be taken as common. From here I will have r, from here 2h, from here L, right. Let's put pi equal to 22 by 7, r is 0.7, r is 0.7 plus 2 into h. So 2 into 2.4 is 4.8. What is L? L is 2.5. Okay. So this will give you 10 in the denominator. So 22 by 10. From here 4.8 plus 0.7 is 5.5, right. 5.5 plus 0.5 is 6. 6 plus 2 is 8. So this is 8. Okay. Or what we could have done is, without cancelling it, we could have written 22 into 8 by 10 itself, because it will be simpler to convert it into decimal form now. 176 by 10. So this is 17.6 centimeter square. This is the total surface area of the remaining solid, that is this one. Okay. Okay. This time we have got a solid cylinder and we are making a wooden article by scooping out a hemisphere from each end, right. We have done a question where we had a hemispherical depression on one side. This time we have got two such depressions, okay, right, because we have scooped out from both the sides. If the height of the cylinder is 10 centimeter, let us say this was my cylinder. The height of this cylinder is 10 centimeter, okay, and its base radius is 3.5 centimeter. So this is 3.5. Okay. We need to find total surface area of the article. So we have got these two surfaces this time, right. These are depressions. If you look at the cylinder, look at the face, it will be like this curved depression. So what will be this curved surface area? This curve, it will be 2 pi r square, where r is the radius, right. So 2 pi r square we will get from this hemisphere, and from this hemisphere we will get another 2 pi r square. Okay. And we need to add this curved surface area of the cylindrical part, which is 2 pi r h, where h is height of the cylinder and r is radius. Okay. So total surface area of the article is equal to 2 pi r h. This will give me curved surface area of the cylindrical part plus twice of area of hemispheres, curved surface area of the hemisphere, 2 pi r square, where r is radius for both hemisphere and the cylinder. H is height of cylinder, right? So this is what we need to calculate. R we already know is 3.5. So let's put value of R in it. So if I take 2 pi R common, from here I will have H, from here I will have 2R, right? So 2 pi is 22 by 7, R is 3.5, 3.5 is half of 7, so I will put it 7 by 2. What is H? H is 10 plus twice of 3.5, which is 7. Okay, so this 7 goes, 2 gets cancelled, 22 into 17. Okay, you can calculate it like this. This is 374 centimeter square. This is the area of the solid after scooping out the hemispherical portions, right? So this was about this first exercise. I hope you have understood how to calculate surface areas of combinations of solids, and also if we take out some portion of a solid, how to visualize which surface has disappeared and which new surface has come into picture, right? The surface that has disappeared, you have to subtract that area. Surface that has come into picture, you have to add that area, right? Okay, thank you.